My name is Ann Lynnworth, and I will be your presenter for this session. Our topic today is Web-Centric multi-device applications, with Delphi, of course. Today I will be sharing the story of one of my customers. Taylor Technologies developed a complex suite of apps, collectively called SureTreat. When Taylor had to make a decision for the client-side devices in 2011, they could not use FireMonkey. But now with version XE7, FireMonkey can be used. In the second part of this presentation, I will show you sample server and client-side projects. In these samples, Delphi VCL will be used server-side, and Delphi FireMonkey will be used for an Android client app. And one item of housekeeping. Links for all the resources important to this presentation are provided on our CodeRage webpage. You might be wondering why there is a picture of a cuttlefish on this slide. I have seen cuttlefish in the wild, and maybe some of you have too. They have a remarkable ability to transform their visible outsides to blend in with the surrounding sand, seaweed, and coral. Depending on the situation, they appear to be completely different. This is what Taylor's Web-Centric application does. It blends in and transforms itself to be exactly what is needed for a specific viewer. If you only look from one angle, you would miss most of the magic. The case study part of this session is concerned with the SureTreat software. As this is a live commercial venture, I cannot tell you everything about how it works. The second part of the session covers a live website that's sponsored by HREF Tools. For that site, I can show you the Delphi source code for both the server and the client-side projects. Okay, what are we really talking about here? What is a web-centric application? I will answer that question for you first, very simply, and then in great depth. First, let's talk just in terms of software technologies. In a web-centric application, the server cluster delivers dynamic and static content over HTTP. This content can be prepared and served by a wide range of technologies. Only a selection is shown here on this slide. Taylor Technologies chose to use Delphi Win32 with WebHub, plus HTML5, CSS3, JavaScript, and of course graphics and video. In 2014, the client side as well can be implemented with quite a decent range of tools. Due to deadlines, Taylor Technologies had to use different languages for different devices. Here you can see a breakdown of how each SureTreat application was created. Objective-C had to be used for the Apple devices, and Java had to be used on Android. I will explain more about the SureTreat apps as we go along. The SureTreat ecosystem is complex. However, we can start with a simple overview. It starts with a water sample taken from the pool, which is then tested chemically. An expert system analyzes data about the pool in conjunction with those water test values and recommends specific actions to fix problems and maintain optimal water quality. The report says exactly how much of each chemical is needed and gives the sequence and timing for treating the pool. In some cases, the owner of the pool might want to do the testing, or they might hire a professional to service the pool. The water sample might be given a quick 40-second test using test strips, or a 5-minute in-depth analysis. The testing might be done on-site at the pool using a phone, or at a pool supply store, or at a kiosk in a shopping mall. The products that are recommended might be chosen to reflect the financial interest of the pool service professional, or of the pool supply store, or of the retail chain. The language in which the whole app appears might be English or Spanish. The units might be gallons or metric liters. The logos might be tied to the pool professional, or the pool store, or the retail chain. This chart shows the SureTreat feature matrix. But why isn't every feature available on every device? Some features depend on the built-in camera that is in a tablet or a phone, so they only work on those devices. Management features are confidential, so they are never surfaced in, say, the retail kiosks. The so-called Windows Workstation is a dedicated combination of equipment located in a pool supply store. In addition to a Windows desktop computer, they would have specialized test equipment connected over USB, such as a Taylor-Wise Lab or a digital strip reader. Where did SureTreat run? During the summer of 2014, the SureTreat kiosk app was deployed for one of the largest retail chains in North America. Kiosks were installed in hundreds of malls, some of which are shown here. Where did SureTreat run? Here's the hardware and software answer. The server cluster ran initially on dedicated servers in Southern California. It was moved to the Microsoft Azure platform in September. A pair of Windows servers handles both the database and the web application. Email and large media storage for videos and so forth are handled by Amazon Web Services located in USA East. Let's back up for a minute and talk about why anyone would want to use a web-centric approach involving Delphi and WebHub. Number one, agility and maintenance. Roughly 90% of the source code relates to the server-side implementation. This means that phone and tablet apps can be relatively simple and completed quickly. Number two, scalability. As of October 2014, all of the web domains of all the active brands are served from one Azure machine. However, any single brand can be pulled out to a separate machine and the identical binary executable could be used to run it on that separate machine. Only DNS would be changed to point to the new server. So for example, if this were rolled out to a retail chain in Brazil, they might decide to host on a server in South America, in a data center there, for that brand. This slide honors the amount of effort and dedication involved in a project of this size. Taylor is 3 years into the project now. At the beginning, the idea was for a single dedicated iPhone app that would use a little dynamic HTML for its reports. They have come a long way since then. Okay, how? How is a project like this architected and implemented? 3 keys to success. The first is define the scope and URL patterns. In the case of SureTreat, this meant animated discussions. Eventually, they were able to distill a matrix of use cases, hardware, and URLs. One domain is used for each co-marketing brand. Subdomains are used to let the web application know what type of face to present to the client device. To further identify the request, various combinations were used in the URL. The presence of phone meant to provide a small portrait user interface. The presence of tablet told the app to provide a larger landscape interface. The second key to success is to uniquely identify everything. That makes it possible to have conversations about the design, to spec the API, and to implement it. Color coding was used in the diagrams to let phone and tablet developers know which part of an app they were responsible for, so they could focus primarily on the red pages. The third key is the technique of trading control back and forth between the native app on the gadget and the browser component. I call that technique the intercept. It is simple to learn and very powerful. And I'll show you exactly how you intercept when we get to the sample project. Okay, now let's really dive in to look at SureTreat. At this point, you probably believe me that this SureTreat application does a lot of work. I thought you might be curious to know the amount of source code required for a project like this. The counts shown here were done on the server-side codebase in mid-October. It was a pretty big project, no matter how you slice it. The important point here is that all of these files work together to serve up the dynamic and static content over HTTP. Okay, now we are going to spiral around the SureTreat web application and view it from different perspectives, starting with how the technical leader communicates to the developers responsible for the client-side apps. I was given a temporary developer login so that I could show you a little backstage. After logging in, developers can see the product matrix. This helps emphasize the unique name for each software product that a subset of users will end up experiencing. Developers can read about the API and see example JSON responses. Developers can review all the flowcharts and check the names of the pages that they need to worry about. In the API spec, developers can see example JSON code in detail. Much of the JSON is fixed for a particular response. The parts that are dynamic are shown in blue. That way the client-side developer knows to focus on parsing out only those values. Next, I will show you a bit of the SureTreat API Explorer. This was built for training and testing purposes. It is optional. It was implemented in JavaScript, so it works on any browser. Client-side developers use the API Explorer to learn about data structures and to see how the JSON goes to and from the server. The server-side developers use it to test everything, long before any client apps exist. So step 1 is to initialize an application data object on the client side. Step 2, we use the so-called object inspector to see what is inside any required object, any property. Step 3, select one of the API requests to learn about it. In this example, we're looking at getting the video list. After parsing the response, the developer goes back to the object inspector to see how the JSON data should be placed into arrays and so on. What you're seeing here is the interface that enables marketing and design specialists to maintain the video files, while the client-side application knows exactly that a new version is ready for download to use inside the client-side GUI. This is like an auto-update feature, just for the video content. Video content is needed in SureTreat because it shows the end user how to carry out the actual water testing steps. You will get to see that in a moment. Of course, the server-side database stores the actual video URLs and the version details at the time that the marketing and graphic design people upload that new content. With the API Explorer, a client-side developer can experiment and learn exactly how the stages of bootstrapping, registration, and normal operation proceed. Now let's walk around and see something completely different. Let's see the view of a pool owner who is concerned that the pool water smells too much like chlorine. What you see on the screen is the actual SureTreat iPhone application running through a simulator in Firefox on Windows. The content inside the black frame is real, but the pool store, Rubber Ducky Pools, is one that exists just for marketing demonstrations. Step 1 for a homeowner is account setup. The biggest factor involved in accurate pool treatment is the volume of the pool, how much water is involved. Many pool owners do not know their pool volume offhand, so a small calculator is available to help them get a good estimate. After setup, we are ready to run a water test. The pool owner needs to dip the chemical test strip in the pool water for a set number of seconds. The phone app displays a video to explain the timing. The pool owner then places the water test strip next to a calibration label and uses their phone to take a photo. The camera takes the photo automatically at the end of the countdown. The pool owner might need to report additional symptoms. The data is posted back to the server application and a report is returned. The phone app has an interactive report where you can open up each section to read the full detail. This is where HTML content really shines. Now remember, everything you just saw was based on web content except for the part where the device app made the camera take a photo. Now let's walk around and see what SureTreat has for the pool service professional who does regular maintenance visits. For this example, we'll see the tablet version, landscape, instead of a phone version. Again, we're looking at a simulation of the real content. Everything but the black frame is real. Notice that the same application logic happens here on tablets as in the phone app. However, the screen layout, navigation, and styling is different. This is accomplished by having the server-side app generate dynamic HTML, CSS, and JavaScript. For our final perspective, let's walk around and see what happens for a person who owns a pool, has a water sample, and has brought that water sample to the shopping mall to use a kiosk for testing. In the kiosk recording, the content is real, but the logos and colors have been changed for this presentation. If I had a few hours, I could show you many more perspectives on this magic web application, but you probably get the idea. One web application can shapeshift itself for many different use cases, brands, and gadgets. Personally, I'm looking forward to the Google Glass version of SureTreat. I hope that by this point you are wondering how this can be done in Delphi. That is what we will look at next. The sample application is a miniature compared to SureTreat. Nonetheless, I will be able to show you all the building blocks. I am not trying to convince you that this is the only way to build all web-centric applications. There are general ideas here like the intercept that apply to any FireMonkey TWebBrowser wrapper, regardless of how the server-side app is built. WebHub has advantages when there are so many multis, like multi-brand, multilingvo, multi-device, but you can use any server-side technology and still leverage it using a relatively simple FireMonkey app. One last point. I should mention that for the Windows Workstation Retail app, that one that runs in the pool supply stores where there needs to be a lot of integration between the custom GUI, the high-end water test equipment over USB, plus having online SureTreat content, this app needs to be done using Delphi VCL Win32 and an open source wrapper for Google's Chromium product. The FireMonkey TWebBrowser component is simply not available for the Windows platform. Using Ceph3 is a great way to get all the features of Chromium, including full HTML5 and CSS3 support. Welcome to part 2 of this talk, where we will focus on a sample application so that you can see some Delphi source code. I chose the Delphi Prefix Registry website for this purpose. Although it shares some code with the other WebHub demos, its website design, domain name, and production server are independent from the rest of the demos. For CodeRage, I needed an excuse to use a hardware sensor on the Android tablet. I decided to build a pricing feature based on device location. Depending on the country of the person running the tablet app, the donation page on the registry website would ask for a suggested donation. The exact price would be adjusted based on the Big Mac Index published by The Economist last July. I created a miniature API to let the client app self-configure itself. So the FireMonkey app needs to do some bootstrap requests to get some graphics, some button captions, and the starting URL. The server-side app is compiled with Delphi VCL using WebHub components. Calculating the adjusted price is done server-side. The Big Mac Index pricing figures are stored in a tab-delimited file, also server-side. I would like to give you an overview of WebHub. There is a runtime connection layer, plus components and patterns that a Delphi programmer uses when developing a custom EXE. When deployed, the WebHub connection layer loads with the HTTP server, which is usually IIS on Windows. This includes an IZAPI extension, which shows up as a so-called application inside of IIS. The connection layer also includes WebHub Central, which runs as a service. These pieces connect to as many custom EXEs as the developer cares to build and deploy. Additional instances give support for higher traffic. Usually, the custom EXE talks to a database. The database server is often located on a firewalled machine nearby on the local area network. A WebHub application EXE is compiled using Delphi. When it runs server-side, the EXE loads configuration data from XML, and based on that, loads WebHub techo files that define the dynamic page content for the website. On the client side, whether in Google Chrome on Windows or Safari on Mac or with TWebBrowser on an Android, it doesn't matter, a URL is requested, and the response document generally contains HTML syntax. That HTML document may link in dozens of additional resources, such as cascading style sheets, JavaScript, and graphics. The WebHub runtime software takes care of the HTTP and IZAPI connection logic so that a custom application can focus just on the minimal tasks necessary for a given site. For deployment on a Windows machine, IIS is typically used for the HTTP server. An IZAPI runner is included, precompiled. Every WebHub application needs an identifier known as an app ID. A single website domain could use one or many app IDs. A single compiled EXE instance built with WebHub components uses one app ID at a time, but could use different ones at different times. And a given app ID could run and serve pages for one or many domains. The app ID links in to a rich XML-based configuration system, which is surfaced in the ZMadmin GUI. This is where we can enable certain features on development machines and disable them on production. Input includes the starting URL, data from HTTP headers, and posted data values. Output is a UTF-8 document, usually HTML5, but it can also be JSON, XML, CSS, or JavaScript. The incoming URL will generally contain an app ID and a page ID, and from there, the WebHub connection layer gets the control through to your custom application. WebHub pages are declared in special syntax in so-called techo files. WebHub techo syntax wraps and extends normal HTML. The WebHub app will send the content of a page automatically. When parentals are encountered, it will expand for you. This is the Escher strip part of WebHub. During processing, Expressions within parentals can expand to execute WebHub action components, to display published properties using RTTI, and also to include WebHub droplets defined in techo files. From there, further expressions can call even more expressions. This is powerful because the designer can put some logic inside Delphi and some features outside Delphi. Anything left outside in techo files can be changed by a webmaster. The site can be updated without needing to recompile the exe. WebHub projects are generally organized around a tdata module containing a TTP project component. TTP project is used instead of having extensive custom logic in the project source file. The TTP project component has events that help the developer sort out the sequence of module creation and initialization. WebHub apps are compiled to be Windows services by default, and the same binary can run as a regular app on a development station. WebHub apps can easily include or exclude GUI panels. Often the GUI is needed during development and hidden on production servers. Let's have a very quick look at the onExecute method for one of the web action components used in the registry sample. This is where the registry feeds JSON back to the client. The logic for identifying which portion of the API has been requested is handled here in Delphi. The actual JSON is defined outside in a techo file. Let me show you a few pages from the registry site. The main thing people do on this site is check whether a component prefix is available. This is still done by a quick alphabetical jump to a portion of the database. If we click on the letter M, we can see the M prefixes. For this CodeRage presentation, I added the donation feature. A site visitor could donate the value of a Big Mac. There is a link here which will let us get a price for another country. This is for training purposes, not for high security. So let's try Brazil in Portuguese. Okay, new price for Brazil, $5.86. Now let's go into Developer Tools. Here you can experiment with the API in a really simple way. If we ask what the latest versions are, we can see the JSON coming back from the server. This is coming back from the web action onExecute code that we saw a moment ago in Delphi. Here you can see the WebHub output panel on the registry executable on a developer machine. Developers check this panel when they want to confirm what was sent out to the client. Now let's go into the Delphi code for the client-side Android app built with FireMonkey. I'm using the location sensor component to determine a latitude and longitude from the device. I'm using the geocoding feature to turn that into a country name. I'm using the Indie HTTP component to bootstrap the app. This involves calling each of the URLs that we saw in the API Explorer. JSON comes back and the data gets copied into some record structures. If you are interested to see one way of doing that with UTF-8 content, see the implementation of the client init function. For now, trust me that these record structures get filled in with data from the API calls. When the client app runs, it shows the FireMonkey splash image. It does the Indie requests and downloads some extra graphics that are SVG files. SVG files are scalable, so if we display them using TWebBrowser aligned to client, they will automatically fill the screen for any client device any size. One graphic is a welcome message and the other is a goodbye message. The idea with these graphics is that a marketing department could make new files at any time. As long as the JSON information is updated in the techo file, the client app will auto-update itself to use the new image. Another part of the client initialization process is downloading translation text for the 3 buttons in the app. The JSON will give us words in English and Portuguese for go, hide, and exit. The client also uses the API to find out its starting URL for launching into the web content. As soon as possible, the client displays the welcome graphic. The idea is that the graphic would often be cached locally so it can be loaded from the documents path straight into TWebBrowser. The client then navigates to the starting URL. In short treat, this idea of the intercept was implemented in Objective-C for Apple devices and in Java for the Android devices. To do it with FireMonkey, we program the onDidStartLoad event of TWebBrowser. For our registry sample, we want to take control when the surfer tries to go to the donation page. That is when we want to jump in and announce the country based on the hardware location sensor in the device. If you are really paying attention, you will be wondering why I hard-coded the name of the donation page here instead of pulling it from my records from the API. I really should have. I just ran out of time. So we append the country code to the URL and return control to TWebBrowser. This is done by telling it to navigate to the modified URL. There are more secure ways of passing data to a WebHub session, but this will do for now. So let's see what happens when this runs. I will show it to you running on my development network. Now here's a quick tip. Use a public domain and map it to your LAN numbers for testing gadgets without any complex proxies. So when you see these screenshots, if you see modulab.com, that's my local development network. The client app also intercepts when the surfer switches between English and Portuguese on the Delphi prefix registry site. When that happens, the client app updates the text property of its buttons to use the translated wording. Now let's try putting some of this together. I just received word that the text for the donation page has been translated to Russian. Yes, that looks like Russian to me. We should be able to edit 2 of the techo files to add the Russian translation. We should not have to recompile anything. Not server-side, not client-side. First, we add a link that lets the surfer select Russian in the page footer. This should work. Second, we update the JSON content in the API file to include the Russian words for go, hide, and exit. I don't actually know any Russian. I just chose some short translation words from Google Translate for this. Now we use any browser on any device to refresh the running WebHub application. That takes a second or 2. So now we scroll to the page footer, and yes, we have our link. Let's see whether the content can actually translate. Well, it looks like it worked in a regular web browser. Let's test the Android side now. I told Delphi to run the Android app again. At first glance, it looks about the same. But we do have a link to Russian in the footer. Let's try it. Aha! That looks good. Let's check the donation page. How about that? It actually worked. Now that is a web-centric, multi-device application built with Delphi. Working on projects like this is like doing a 100,000-piece jigsaw puzzle. The result is amazing, but it takes some patience and very good organizational skills. All the links for resources mentioned during the presentation are on our CodeRage 20 webpage. If you are interested in doing this type of work, please look there for the Help Wanted link. In general, if you would like to reach me to talk about web-centric application development, please stop by my online office. It is open Monday through Friday, late afternoon in California. And I hope that you have enjoyed today's presentation and that it has given you some very meaningful food for thought. Thank you so much for listening.
What would the learning curve be for beginners to learn WebHub to create web-centric multi-device apps?
That's a great question. Somewhere between a few days and a few years. It really depends on what your starting point is and how difficult of a project you're trying to build. And whether you're an organized person or somebody with Alzheimer's, not to be rude, but there's a lot to learn and there's a lot to remember and there's a lot of puzzle pieces. And some people are very good at memorizing everything and stitching it all together and kind of understanding it. And some people need to go through it a few times. We do have a lot of resources aimed at beginners. If you follow some of the links from my CodeRage exhibit hall page, you can find your way into the WebHub demos. And in the page footer of all of those demos, there are links for view source, which will let you see the WebHub Techo code and the Delphi Pascal code. Of course, you can view source and see the HTML and the CSS anytime you want. And there's also a download link. In the download link, you can get to the Subversion repository and have all the source, and you can stare at it and figure it out. Over the next few weeks, assuming that there is some interest following up from this, I hope to be putting up some more seminars that are fairly short and fairly targeted to explain how to do the main things that beginners would need to get through. The other thing about Foundation is that it helps a lot if you've picked up some books on HTML5 and CSS. CSS is the cascading style sheet system. And if you look at something like the Zorb Foundation libraries, you can grab these fantastic systems that other people have put together for the web and get responsive design almost for free, almost immediately. So, joining in now is a lot easier than joining in 5 years ago.
That's true. A lot's changed in the past few years when it comes to...
Yeah, the jQuery libraries that are out there are off the charts. So we should have some exciting announcements in the near future.
So your website, Code News Fast, that has the cache version of the newsgroup articles. What searching technology do you use behind that?
Oh, well, I should have paid somebody to ask that question. The searching technology behind it is Rubicon, which is also our product. And I've featured Rubicon in some previous CodeRage conferences. And you can look on our website under hrefcom/Rubicon, and you will find some links to the training videos that I've done for that.
That's what it was. Rubicon. I'd used Rubicon before and found it to be a good...
It's a great tool.
A great tool.
It's a great tool, and we bought that from Tamarack some years back because they needed to go in a different direction, and we needed to upgrade it for Unicode. So we took it over since Delphi Unicode.
Okay, yeah. So yeah, I used Rubicon before. The thing I liked about it is it was, because I looked at a few different indexing searching tools, and the thing I liked about Rubicon compared to the other ones is you really were able to just get into it and use it from your Delphi application exactly the way you wanted to. A lot of the other ones were essentially a black box that you kind of said, hey, index some stuff and tell me what you find. But Rubicon, you really were able to get into it and take control of it. And I thought that was a really good feature about that.
Thank you.
Yeah.
Yeah, I mean, I was hooked on Rubicon, and that's why I agreed to take it on.
Oh, yeah.
To do the maintenance for it, because I just couldn't see switching to any other technology. And it is extremely fast because the index is cached, so... I think searching it's about a 15 gig Firebird database running behind Code News Fast, and I think the searches are quite fast.
Okay, so here's a follow-up question to that. Jim's going to database Bloomberg News. It's about 1 million stories a day. What database would you recommend he uses?
Can you just tell me the per day number again?
He said 1 million stories a day.
Right. That's interesting. Well, look, it depends on where the database is and where the index can be and how much of that you really need to index. A lot of times those news stories, you might index just the abstracts, for example. So the indexed content might be a subset. And then what you do for the index can be a separate decision. So let's say, for example, that you didn't control the database of the news. Maybe that's in Oracle or it's in some sort of internet format, like even an Amazon database, right?
Right.
The index part of it that Rubicon works with could be something closer to where your client app has to live. So if it were a WebHub app searching it, it could be a Nexus database on the server. If it were an Android thing, it could be an IB Lite database inside the gadget, for example. That's where the index could be. So the searching and the client app would want to be as close together as possible. And then when you retrieve back the articles that are relevant to the result of the search, then you would be going and doing those network requests that might take just a smidgen longer.
Okay, so Rubicon would work on Android. You could have an Android app that used Rubicon against an IB Lite database?
I believe you could. I've done some experiments with Rubicon with FireMonkey on the client side, fairly primitive experiments. That's why I'm not featuring it this year, because I didn't want to jump up and down too much yet. But yeah, in principle, Rubicon connects to a very wide range of database systems, including FireDAC, including DB Express, including all the AnyDAC DevArt products, IB objects, lots of things. I'm forgetting some people, Nexus DB. So anywhere that you can get the Delphi product to connect to the database, it'll work.
Yep. That was one of the things I remember about Rubicon is I could use whatever database I wanted to.
Yeah, that's why it's a maintenance project.
Yeah.
So it usually ships right after each version of Delphi for the built-in bridges that Embarcadero supports. So things like FireDAC, we have support for right away. The bridges, for example, DBI SAM or Elevate DB, that come out a little bit later after each Delphi release, we then support that a little bit down the track.
Excellent. All right. Well, oh, excuse me. If anybody has any other questions for Anne, go ahead and post them now. Thanks, Anne, for stepping in at the last minute to fill in and with your session here. I appreciate that.
You're welcome.
It was informative, and actually it was very entertaining to put together a good way to keep me engaged, as I have all these things going off in my trying to keep up with my work here as well. So
good.
It's great.
Good. And could you believe that the spiral Embarcadero Center? I could put the caption on the photo.
I'm sorry, one more time. Oh, it's from the Embarcadero Center.
Yeah.
Oh, really? I did not know. Yeah. Didn't catch that.
Complete coincidence, but
well, it was funny. So this is an aside story. The place I was working at when Embarcadero bought the Delphi tools, the development tools from Borland, was called the Embarcadero Center. It wasn't the Embarcadero Center in California, or no, it was owned by Embarcadero Property Manager. That's what it was. Embarcadero Property Manager owned the building that I was working at the time. And I was like, whoa, that's so cool. Anyway.
Yeah, sometimes the writing's on the wall.
It is, yeah. You mentioned adding EXCs would enhance performance. How does this work?
Oh, that's a good question. That's sort of the core technology behind the runtime layer. There's a hub that runs as a service, and as the requests come in from the HTTP server, the hub will delegate them to be run by these different processes. And say 3 servers came in at the same time, so to speak, same time, those instead of being done sequentially, they could be done in parallel by the different processes. And the reason that they're done in processes and not simply in threads is this. When you're developing and when you're debugging a WebHub application and you want to deal with a particular page that's being generated, you have control of all of the resources in the EXE, which means you can be thinking almost the same way that you would when you're writing a single user VCL application. In other words, it's completely straightforward. You can use the debugger, you can do everything linearly and know what's going on, and there aren't crazy things happening from every corner at all times, as there would be if all of the servers could interrupt each other and be a threaded nightmare. So the way the WebHub model works is that every page request is processed beginning to end within a single EXE. And then as soon as it's finished, which might only take 15 milliseconds or something, as soon as that page request is finished, the next person or next surfer gets exclusive use of the EXE. Yeah, so if you want to support a huge amount of parallel traffic, you would have maybe 10 or 20 EXEs running in parallel for the same app ID. But usually you don't need to. Usually you can get away with 1 or 2 instances. I publish my counts of instances to sort of prove this to people. I'll give you the link in a second. If you look on one of my pages, I have a chart where I show the servers that I manage and how many instances are running. So you can look up and see how many instances are active on Code News Fast or the demo servers and things like that. There's not that many.
Okay, great. Very cool. Well, thanks. Thanks again, Anne.
You're quite welcome. Can I give a part 2 to that question?
Yeah, absolutely.
Part of the trick to not overloading your WebHub server, right, is to offload a lot of the slow things and the large files to alternate servers. I don't know if you remember back, but there was a slide where I showed the Amazon resources being part of the solution. So I use Amazon S3, generally speaking, for all of the graphics, video content, even sometimes the style sheets in the JavaScript, so that they will load from the Amazon CloudFront system, which will be virtually instantaneous for anybody and has no performance impact on the main server that's doing the logic. And so also things like email, you can offload those onto Amazon servers. So you don't need to have 100% of everything served by one machine. You can distribute it out sort of by the nature of the request. And that's done simply by making the images go to the correct URL rather than to the primary domain. Not a difficult thing.
Okay, good tip. Great.
Okay. So I have open office hours. If anybody wants to catch me later, they can catch me there.
That's a good thing. And the link for that was, let's see.
You can get it to it from our exhibit booth. I'll give that. That's probably the easiest.
That's great. All right, perfect. All right, thanks
All right,
again,
well,
Ann.
thank you for fitting this in.
Oh,
and thanks everybody for listening.